We are going to solve conceptual problem, NEET based problem. A wire of resistance 2 ohm per meter is bent to form a circle of radius 1 meter. The equivalent resistance between its two diametrically opposite points A and B is dash. Option given, first option 5 ohm, second option pi by 2 ohm, third option 2 pi ohm, fourth option pi by 4 ohm is given. Here we assume this is the wire which is bent in the form of a circle. This point A, this point B, these 2 points are taken diametrically opposite points. Now we are considering radius of this circle as 1 meter because 1 meter is given. And one more thing is given, for 1 meter wire resistance is 2 ohm is given. For 1 meter wire resistance is 2 ohm is given. That means here between A and B only we need to find effective resistance. Between A and B only we need to find effective resistance. That means here this is half of the semicircle. Half of the semicircle length is pi r meter. Half of the circle length is pi r meter. So this is pi r meter and this is pi r meter. So here this r is equal to 1 meter, so that this length becomes pi meter. Similarly, here also r equal to 1 meter, so that here length becomes pi meter. Here given that resistance of 1 meter wire is 2 ohm, so that pi meter wire resistance becomes pi ohm. This is pi ohm. This is pi ohm comes. And here also 5 into 2, because 1 meter wire resistance, 1 meter wire is resistance is 2 ohm. So that pi meter resistance is 2 pi ohm, because each meter resistance is 2 ohm. So that pi meter resistance 2 into pi ohm. Similarly, here also this resistance also 2 pi ohm we are getting. That means here this part act as a one resistance and this part act as a another resistance. See here, this half of the semicircle act as a one resistance and this semicircle act as a another resistance. See here, this resistance we take here as a equivalently 2 pi ohm is there. Similarly, this resistance we take as a 2 pi ohm we take. These two resistors are that means this is one resistance and this resistance. These resistance are connected in parallel. So we connect in parallel. We are connecting in parallel. So this point is A and this point B. And we know that effective resistance in parallel combination, effective resistance in parallel combination is equal to 1 by R1 plus 1 by R2. Here we take this one as a R1 resistance. This is as a R1 resistance we take, and this is as a R2 resistance. Here R1 and R2 are equal. So 1 by Rp is equal to, we are getting 1 by 2 pi plus 1 by 2 pi. 1 by 2 pi plus 1 by 2 pi is 1 by pi. 1 by pi. This 1 by Rp. So Rp is equal to, we are getting pi ohm. So answer is pi ohm. Otherwise, in simply we can take that when equal resistors are connected in parallel, effective resistance is equal to 1 by n times of one of the resistance. 1 by n times of one of the resistance. Here n is number of resistors. Here number of resistance, equal resistors. These equal resistors are connected in parallel. When equal resistors are connected in parallel, effective resistance in parallel equal to one of the resistance divided by number of resistance. Here one of the resistance is 2 pi, number of resistance is 2. So that answer we are getting pi ohm. So in this option, if you see here, first option is the correct. First option only we are getting pi ohm we got.